Good morning and welcome to Waters Iron Works. It is a very chilly morning here in Austin, Texas. We're just below freezing, so I may be trying to stay a little warmer than I normally do out here. We're going to be jumping around the ABANA curriculum a little bit. If you're following this in real time as I publish these videos, we've been focusing on level 1. We are going to jump all the way to level 2.10 and talk about drifts. I'm actually helping teach the level 2 online Zoom ABANA course, and my section's coming up and I'm covering drifts and bolster plates. So need to get some videos in for that course. If you are looking at a way to get into the ABANA courses and you don't necessarily have somewhere local that's teaching them, I did the level 1 online Zoom course just to kind of see what it was like. It was way, way better than I expected, honestly. And so good that when they asked if I wanted to help teach the level 2 course, I said, yes, please sign me up as an instructor. So helping to do that. Highly recommend those courses for the price point, especially. I think the value is 100% there. All that aside then, let's talk about drifts. We'll talk a little bit more in depth about some of the ideas behind drifts, what they're doing, how you can use them. And then we'll go into making the 2 drifts that we need to make for level 2 ABANA. In level 1, we made a round punch and a round drift to go along with it. This one I think we made out of S7 steel back in that video. In this series, we need to make a square drift and a diamond drift. You might ask, aren't squares and diamonds the same thing? I mean, it's just the angle that you hold it at, right? This way square, you turn it on its edge, and you got a diamond. Yeah, that's true. For the course though, and where it's gonna make a distinction is in the front on these. So the square drift is going to have a round taper to it so that we can pair it up with a round punch. And then the diamond drift is going to be paired up with a slot punch that you'll need to make. And in order to do that, we need to make sure that we've got this set up so that it'll fit into the slot. So we wind up with a bit of a chisel, and that chisel needs to be on the diamond, making it a diamond punch. Some of the things as you're making punches that you might be thinking about is what kind of steel am I going to use for these punches? In the level 1, like I said, we used S7. It's a high temperature air hardening steel. That means that I don't need to quench it. It's going to re-harden itself after it gets hot. And that's an important consideration as you're thinking about your drift, right? I've got this little diamond drift, for example. If I made this out of something like 4142, a medium carbon steel, it's going to go into a piece of very hot steel. It's going to spend some time in there. It's not a huge, piece of steel itself. It's going to pick up a lot of heat, and that will tend to ruin your heat treatments on these drifts, especially as one of the ways that drifts are commonly used is if you need to do some forging around a hole and you want to make sure it's staying the appropriate size and shape, you can put your drift in and you work that steel with the drift in there. These things get real hot. So I tend not to make a lot of them out of medium carbon steels. I find that the value isn't there for it. It messes up my heat treatment on it too much. It's a little tougher steel, so they don't mushroom out and things like that quite as quickly. But if I'm going to bother making a drift out of a tool steel, I am probably going to look at something like S7. Again, air hardening so that it gets hot and it re-hardens itself. I don't need to worry about over and over again going through heat treatment processes. But honestly, most drifts I use, I just make them out of mild steel. I find drifts incredibly hard to hold on to. I lose them all the time. And even when I make them out of high carbon steel, man, there's no guarantee it's going to be there next time I need it anyway. Maybe that's just my shop. You might have better luck, especially if you've got a nice drawer or something to keep them all in. But I find making drifts is a pretty quick process. So knocking one out of mild steel that's going to be the exact shape and size that I need for the project that I'm working on takes a few minutes, and it's pretty easy to do. So I normally make them on a project by project basis. If I had something and I was punching the same hole a lot of times, then I would probably make it out of a higher carbon steel. If I had a really large drift, hammer eye drifts, axe eye drifts, things like that, again, those take some more effort. I am going to be more inclined to make those out of a better steel. Those are also larger drifts, and so you can look at medium carbon steels for that. It tends to hold up reasonably well. But again, if you're going carbon steel, those air hardening and especially steels that are designed to work at high temperatures are good choices for the steel that you might use. What we're going to be using today, though, is just 1/2 inch mild steel. This is square bar, 4.5 inches long. We've got to make, like I said, for this, the square drift and then the diamond drift. And these are extremely similar. So what we're going to do is we're going to make the square drift and then we're going to turn it into the diamond drift. You'll see both versions of it, but we're not going to make an extra square drift for this video. So as we get into looking at making our drifts, there's a couple things that we need to think about when it comes to drifts. One is that expansion and contraction of steel as it heats up and cools down. If we want to pass a 1/2 inch square bar through a hole, our drift needs to be something like a 1/64 over size, so that the steel as it cools will cool to that 1/2 inch mark, and we'll still be able to pass things through. If our drift is exactly a 1/2 inch, when that steel cools after we've drifted the hole, our 1/2 inch bar is no longer going to pass through it. And we want, right, if we look at, let's kind of zoom in here on the anvil. So let's talk about the anatomy of a drift and what we've got going on with it. Back here, we've got the struck end of the drift. This is where your hammer is going to be hitting. We want to leave this nice and fat. It is very easy to take these too thin when we go in and put our taper. And we do want a taper that is at least as long as the thickness of the material that the drift is going to be going through. We're using 1/2 inch material that we're going to be drifting for the level 2 course. I'm going to take this to 1.5 inch drift or so. We then have the body of the drift, and somewhere in the body, I normally do it somewhere either halfway mark to about 1/3 of the way back on the drift. Here we want the thickest part of our drift. So we're going to go in, we're going to do an upset as the first step in creating this drift. Make sure that we've got that extra thickness we need so that it works after we drift the steel. Here we can have either a taper on the front, a gentle taper, or this can be just kind of the original parent thickness. And then you do want a gentle taper up here on the working end. And you don't need to take these super thin, right? They've got to match up with your punch that you're going to be using. This one is probably a little thinner than I need. I do want to make sure I've got a gentle taper here though. The more abrupt and steep that taper is, the harder this drift is going to be to use, the more drag it's going to put on the material that it's going through. At least 1.5 inches on a drift like this, you could taper it all the way back to the halfway point. Just don't make them excessively long. There's no need for that. The working end here though is really one of the most important parts of the drift, right? It needs to match up with whatever you're using. So we've got a round end on this and it's going to line up with my round punch. If I'm looking at something like that slot punch here. So this is a 1/16 by 1/2 inch slot punch. I need the working end of my drift to match up with that. And what you're normally looking for is, right, if this is a 1/2 inch, this is maybe a 1/16 under, something like that. Right, these should be relatively similar sizes. You obviously don't want the drift to be bigger than your punch. If it is, then it won't fit in the hole that you just punched. So that is kind of the anatomy of a drift. Again, we're gonna focus on this upset first, and then we'll work on each of the ends. I've got my steel hot. I actually overheated the steel a little bit. One of the questions that I get pretty frequently is, how do I do these sorts of upsets if I've got a propane forge? Propane forge, you put it in, the whole thing gets hot. You know, it's hard to get that isolated heat in the middle of a bar. And the answer, right, is that you just gotta quench the ends and isolate things. This can certainly be an easier process in a coal forge, but you can 100% do it in a propane forge too. So we're gonna come in, work our way through the ice. So we've got our heat isolated, about 1/3 of the way down, halfway down. We're just gonna give it a few hits here. Doesn't need anything crazy. As long as you can feel that swell in there, then you're gonna be good. One of the very common things that'll happen is you're gonna get bending. We've got a little bit here, but nothing too significant. The challenge you're gonna run into, right, is we've just upset this middle section a little bit, you know, 64th or something like that. We don't want to hammer on that section as we unbend things. So a couple different ways you can do it, right? We've got a little bend here. We can use the tongs to hold this up, and I try not to hammer too much on the swell itself, but come back here and give it a blow or two. Or we could hold it, this is a little bit backwards, but with that end up, and then while this is good and hot, hammer on that end in order to hammer it down. It's less efficient than hammering the top of the hump down, but we really want to make sure that, again, we're avoiding undoing the upset we've got. For this, you know, if this was cold and you can run your finger along it and you can feel that you've got a little bit of a swell there, you're gonna have enough. So, I mean, I don't know how well it shows up on the camera. There's a little bit there, and we're good. So now we're gonna work on the struck end, just tapering that in a little bit. We're gonna come in either on the horn or the far edge of the anvil, knock it in a little bit here, and we're gonna take that taper back, making sure not to go into our upset portion. Also making sure to leave things nice and thick. I've got a little bit of an angle on here. Couple ways to deal with that, probably the easiest. Flip it over, hammer it down, upset that a little bit, nice and square. And then I'm gonna come in and heavily relieve these corners. And I really want to make sure that there's no dimension here that is going to be wider than the thickest part of my drift. The goal with that, right, is as this thickest part goes through the material, then it just falls out the bottom, lands on the ground. Again, wound up with a little bit of an angle on it right there. Probably just hit that with the file, or alternatively not worry about it at all. Not gonna make a huge difference. With that end done, we're gonna flip it around and we're gonna work on the front end. Again, we're gonna come in, we're gonna taper this in. This one will be a little bit odd because we're gonna first take it round and then make it into a slot punch. And again, I'm not trying to over thin this, but I want to make sure that it is going to fit into the hole left by my round punch. Assuming that this was going to remain a square punch. And we're just take a nice taper on it here. Let's reheat that and we'll round it up a little bit. So to finish up our square punch, I'm going to come in and I'm just going to work on relieving these corners a little bit here. Ideally, I'd probably take these all the way to round, but if you do, you know, an octagon here, they'll work well enough. And that right there is our square punch set up to go with our round punch. If we want to make this into a diamond punch, we're basically going to do everything the same here, except we won't round this off. So let me bring this back to square. Take a heat on that, get some nice sharp corners in there so we can see what we're doing. So we'll take this back nice and square, maybe a little longer than we need now. We'll definitely have to cut some of the end off. So in order to make a diamond drift, we're going to take our piece, we're going to put it up on the diamond, we're going to make sure that everything is nice and square here, and then give it some nice big blows, moving our way forward. And we're really trying to make sure that we keep our flattening so that these lines are centered. If these are off, then as you put it through and you drift, it's going to move your diamond off the center that you want it to be on. So let's take one more heat. We're going to flatten this out a little bit more. And then I'm also going to make a mark and figure out where our 1/2 inch is, and we're going to cut off the rest as excess. So let's finish up taking this to the diamond. That's looking pretty good. Right, so what I'm looking for is a nice smooth transition. Drifts, it's always important to have that smoothness. This thing is way longer than I need it to be. So we're going to grab a hot chisel. I do want it to be undersized. That's about a 1/2 inch mark right there. So I'm going to come in with my hot chisel and give it a snip right there and cut off the tip of that. So I've got an aluminum block here that's just going to help me not mar my anvil. It's going to cut right through here. There we go. So we're at about a 1/2 inch. I'm going to clean this up real quick with the hammer, and then we'll take it to the vise and file it to the end. Knock that in a little bit. Make sure it's going to fit nicely there. We'll clean that up with a file. What we're really looking for here, let me grab a piece of chalk. Right, we've got a line right there, and we've got a side right there, and we want to make sure that that ridge line is running from this transition all the way down to the tip, or just about to the tip. If this ridge line is coming off and it's going, you know, off to the side right there, that's where you're going to get twisting as this is driven through the material. So this line needs to go straight down to your tip, and this one actually is looking real good. So not a whole lot of file work we need to do there. Let me clean this up, and then we'll take a look at the final product. This is our final diamond drift, right square back here. but designed so that it can fit into a slot punch, and then it is going to take that slot into a diamond shape. If this was a square punch, right, pretty easy. We just need to reorient the bottom of that so that it would fit going through this way, and then it'd leave a square hole instead of a diamond hole. Hopefully this was informative and interesting. We'll eventually get into the level 2 stuff and get caught up to the 2.10 section that we just covered right now, but a little bit of a preview as we're going through the material. Thanks so much, and we'll see you again soon.